Hello class, I'm working out of Algebra 2, 5.8, Solutions to Quadratic Equations. We're going to focus on part of the quadratic formula under the square root symbol. It's called the radicand, and that equals the discriminant. So we're going to be solving for the discriminant with that part of the formula. So the discriminant equals b squared minus 4ac. And we're working from the standard form of ax squared plus bx plus c when we are pulling our a, b, and c values. So be sure those are in descending order. Pay attention to that. Generally they will be, but we have had a couple thrown in that were not before. All right. Your reference chart is on page 219. And when the discriminant is greater than 0 and it is a perfect square, we have two rational solutions or two real solutions. When the discriminant is greater than 0 but not a perfect square, we have two irrational solutions. When the discriminant is equal to 0, which we'll see an example of, I believe, today, we have one rational solution. One real solution. And when the discriminant is less than 0, it throws a complex number, which means in the plus or minus situation under a square root symbol, that's an imaginary number or a compound number. So we call that two complex conjugates. Okay, so that's a breakdown of the chart on page 219 that we will be using quite a lot. So let's look at some examples. If we have x squared plus 4x plus 7, and that's equal to 0, and we are working with our coefficients a, b, and c, a equals 1, b equals 4, and c equals 7. Our formula, which it's always cool to set it at the top of your page while you're working, just for reference. Pop those down on index cards, whatever it takes, is discriminant equals b squared minus 4ac. Again, we've seen that under the square root symbol. In the quadratic formula, we're getting our coefficient terms a, b, and c in the same manner, as we know. So to solve for the discriminant here, but not solve the whole polynomial, we are going to look at just this part, and we would have 4 squared minus 4 times 1 times 7. To substitute in a, b, and c. So that would equal 16 minus 28, and we get a negative 12. If we look back at our chart, d is less than 0, so we have two complex conjugates, and that's an imaginary solution. So we would say that All right. Another example. We have x squared plus 3x minus 8. We're going to just remind ourselves of the discriminant formula, which is under the square root symbol in the quadratic formula. We're going to pull out our coefficients. A is 1, B is 3, and C is negative 8. Plug those in as a substitution. So we are going to have 3 squared minus 4 times 1 times negative 8 is equal to 3 squared is 9 plus 32. So our D equals a positive 41. Thinking it through in the margin, is 41 a perfect square? It is not a perfect square. So we have 2 irrational solutions from our chart. We go back to the chart to check. Okay, another example. We'll have x squared plus 6x plus 9. This is a perfect square trinomial. Our formula is D equals B squared minus 4AC. Our A, B, and C, A equals 1, B equals 6, and C equals 9. Plug those in. We're going to get 6 squared minus 4 times 1 times 9, which 6 squared is 36, and we get negative 4 times 9, so negative 36. D equals 0. On our chart, that is one real solution. I hope this helps with 5.8 in determining the number and type of solutions for the discriminant. I'll see you soon.